Good afternoon, everyone. Magandang hapon sa ating lahat.
Good afternoon, sir.
Okay. Wala pa si Miss Suposo. Perhaps she can join us later on. So anyway, I I I think I told you yesterday that the lecture will be until Monday, but I was looking at the presentation pala. I will be able to finish everything today. So tomorrow will be devoted for an activity so that the presentations shall start on Monday. So Monday will be for your presentations perhaps until the end of the term. Mga more than 1 week lang kasi yon yung naiwan. First 2 weeks of July, I think, yung natitira pa nating time for this term, mid-year term. So anyway, our lecture today will start on another concept called cosets. And before we define what we mean by cosets, we have a theorem first here. So this is important because,
Sir,
yes,
sir, may ano lang po ako, announcement for Monday na po.
okay, sige lang.
Sir, completion po kasi namin sa Monday, sir. That's start ng 1 p.m. po. MC po ako, sir. Cannot join po pala dun sa klase po.
Ano kaya? How about the succeeding days?
I'll try po, makakapag-join na po ako, sir, the following days na po. Yung Monday lang po, sir.
What if, do you have classes, whole day ba yon?
Not sir naman po ng morning. Ay, morning kasi sir, magjo-join po ako yung school po namin may program ng kindergarten integrated school po ako, sir.
So you will not be available the entire day of Monday?
Yes po, sir.
Sige, paano kaya yan? Perhaps we can reschedule. Miss Kanjaw, you will be the first to present, right?
Po, sir.
Sige. Kahit gawin nating Tuesday yung presentation. Okay lang ba yon?
Sige, sige po, sir.
So I'm going to give you Monday as your preparation for the three of you. So you prepare your presentations hanggang Monday. So we'll not be meeting na lang on Monday. The start of presentation will be Tuesday.
Thank you po, sir. Salamat po.
Okay, sige. All right, let's continue with our lecture then. Yes, as I was saying, before we are able to define what we mean by cosets, we have here a theorem because cosets are actually just, we can think of it as a partitioning of a set, for instance, of a particular group. So we need an equivalence relation for that because, again, in the first chapter, the preliminary chapter, we mentioned before, no, that an equivalence relation yields a natural partitioning of a set. So we can see here that particular equivalence relation. And it's denoted by, this is our standard notation for an equivalence relation. Naglagay lang tayo ng subscript na L at saka R. Because we are defining two equivalence relation here. And the order is important. So, the first equivalence relation is actually left-sided. Pwede natin sabihin ganun, na equivalence relation. And the definition is that two elements are related. So, A and B are related. This is our equivalence relation. If and only if, this is read as if and only if, A inverse B is an element of the subgroup H. So what do we have here? A subgroup. We have identified a subgroup normally for the remainder of this lecture. We always assign letter H as a subgroup of the group G. So yun yung definition ng equivalence relation natin. If you multiply the inverse of A and B, and it's an element of the subgroup H, then we say that those two elements are related by this equivalence relation. And similarly, the right-sided or right-handed equivalence relation is defined by the following. So if you look at it, yung lagyan ng inverse ngayon ay yung element sa right side. So two members A and B are related by this equivalence relation if and only if the product of A and the inverse of B is an element of the subgroup H. So if that happens, we say that these two equivalence uh, relations are equivalence classes. Yeah, this is what I mentioned kanina lang. Equivalence relations gives a natural partitioning of a set. So with this theorem, we are ready to define what we mean by cosets. So we have here a definition. Again, we let H be a subgroup of a group G. The subset AH containing, or yes, the subset AH containing the elements AH that is supposed to be small h. Let me change that one quickly. Ito. Yes. Is the left coset of H containing A, while the subset HA is the set supposed to be small HA, where H is an element of the subgroup H, is the right coset. So you see, importante yung order. So depende kung paano natin na-generate itong set. So it's generated by an element of H, A, no, an element of G ito pala. And the set is constructed by multiplying A to all the element H of the subgroup H. If that's the order of creating this set, then this set is considered a left coset. Now, anong ibig sabihin ng multiply an element of G to a set? Because this is a set. This is a subgroup. So it's a set with or attached with the binary operation of the group G. General kasi yun sa abstract algebra, no? We simply say that it's a product or a multiplication. The operation is multiplication. However, we are not referring to the usual multiplication. So, depende pa rin kung ano yung definition ng binary operation of G. So, halimbawa, kung addition, usual addition yung operation, ang ibig sabihin ng AH, an element multiplied to the set is to add A to all elements of the set H. So, addition na yung labas. This is just a general notation. If you're going to do it the other way, ibahin natin yung order. So, magiging lahat ng elements ng set na ito, H na ito, times an element that would be the set generated from it is considered the right coset. So, ano ba ang coset? These are just sets generated using a given subgroup of a group. So ulitin natin, nakaka-generate tayo ng cosets if we are given a subgroup. So this is our baseline. This is where we start. And then simply identify A. And then whatever the operations there, yun yung gamitin natin para mabuo natin yung mga cosets. So left or right cosets. So dalawang klase ang cosets. Either we have left cosets or right cosets. So, cosets are not necessarily subgroup. We always remember that. Ang binigay lang ay subgroup, and using subgroups, we're going to create or identify or construct cosets. Cosets are not subgroups though. So, hindi siya magle-level sa subgroup na ito. To provide you a more visual, to help you understand our definition, let's proceed with let's have our examples. to exhibit the left cosets and right cosets of the subgroup 3z of z. So again, this is simply the set of integers. Kung yan yung binigay, automatic, alam natin dapat na yung binary operation dyan ay usual addition. The subgroup that was given is 3z. So remember, for the set of integers nz, so kahit anong n yan, this time is specific, it's 3. That is, pinakita natin before na that is always a subgroup of the set of integers under the usual addition. So how do we start? How do we start creating first the left cosets? So maaaring dalawa, maaaring isa, maaaring more than 2 yung coset na mabubuo natin. And sabi natin kanina, we either construct the left cosets or the right cosets or both. By definition, we're going to make use of the definition na present natin. It's also here. It's still included in this slide. Gamitin natin yung definition. So, we are given the subgroup. So, in our example, it's 3z. So, nandyan. And then, if we're going to start with our left coset, nasa left dapat yung element A. But because the operation is addition again, it is, ang ibig sabihin ng A times 3z is A plus 3z. Because the binary operation is the usual addition. So, anong ibig sabihin ng expression na ito? 3z is, of course, a set. And for all the elements of this set, ano nga ulit yung set na ito? These are integers na multiples of 3, including 0, of course. So parang 0, 3, 6, 9 to the positive infinity, and negative 3, negative 6, negative 9 to the negative infinity. Yun yung laman ng set na ito. And ang ibig sabihin ng an element, a number, plus a set is to add A to all the elements of the set. So if we're going to let A equal to 0 muna, ano yung ma-generate natin na set? So 0 plus 3z is actually just the same as 3z. Why? Because this is 3z. If you add 0 to all the elements here, the elements will stay, will be the same. So 3z is a left coset of itself. Kasi may na-add tayong element, di ba? May na-multiply tayong element. Pero addition yung operation, kaya na-add. What else? What else? To find for the other left cosets, we're going to look for other element A. So, gawin nating 1 at saka 2. So, let's start with letting A equal to 1 muna. We see that 1 plus 3z is equal to this set. So, anong nangyari? Lahat ng elements ng 3z ay nadagdagan ng 1. So, 0 becomes 1, 3 becomes 4, 6 becomes 7, 9 becomes 10, and so on and so forth. Ganun din sa negative integers. So, negative 9 plus 1 is negative 8. Negative 6 plus 1 is negative 5 and all. So, this set, 1 plus 3z, is again another left coset. What else? If we let A equal to 2, we see that the elements are, so mag-add ulit tayo ng 2 from our baseline na 3z. So 0 plus 2 is 2, 3 plus 2 is 5, ganun. 6 plus 2 is 8, 9 plus 2 is 11, and so on and so forth. Now, when do we stop? Paano natin malalaman kung nakuha na natin lahat ng left coset of a subgroup of a group? We will only stop if we are able to exhaust the group. So, titignan natin ngayon yung mga elements ng mga left cosets na nabuo natin. So far, ilan yung left cosets na nabuo natin? We have 1, we have 2, we have 3. Those are 3z, 1 plus 3z, and 2 plus 3z. So, are these the only left cosets? The answer is yes, because when we look at the elements, and if we take the union of these three sets, it will give us actually the set of integers. So kung i-combine natin yung mga elements, actually lahat meron. So if we start with 0, 0, 1, 2, tapos meron din yung 3, 4, 5, 6, 7, 8, 9, 10, 11. Ganon din sa mga negative numbers. So na-exhaust na natin lahat ang laman ng ating group. So ulitin natin, anong ginawa natin? Using the given subgroup as a baseline, we're going to make use of this definition to form cosets. Cosets are just sets generated using that subgroup nga. And the cosets, the union of the cosets, must be the same as the given group. So for this example, how many left cosets do we have for the subgroup 3Z? So coset of subgroup 3Z, 3. So there are only 3 left cosets. We specify that what we solved are left cosets kasi yung elements A ay na-apply sa left ng subgroup. Ngayon, how about the right coset? Well, for this particular example, it doesn't really matter, di ba? Kung ilagay natin yung 0, so itong 0 ilagay natin sa right side. So ibig sabihin, lahat ng elements nito dagdagan natin ng 0. It's actually the same. Ganun din kapag ilagay natin ang 1 sa right or 2 sa right, ganun din yung makukuha natin. Why is that? Because the set of integers under usual addition is an abelian group. Abelian group is a commutative group. So for groups that are abelian, the left cosets is or are just the same as the right cosets. So see, it's really important to have other information or other knowledge about a particular group that we are working with. So the right cosets are just the same. So ito sila pa rin yung right cosets, although hindi ko nasabi ng specific dito. A plus 3z and the right cosets are 3z plus a, where a is or are equal to 0, 1 at saka 2. We have here a statement for subgroup H of an abelian group G, the partition of G into left cosets of H and the partition of into right cosets are the same. Now, bakit natin tinatawag na partitions ang cosets? Kasi if we observe the cosets, halimbawa sa example na ito, we see that they are non-overlapping. One element is in exactly one set. So we can think of this as a one partition. So one partition yan, another one. We can think of Z being partitioned into 3 cells. So yung 3 na yun yung mga cosets, left cosets na nakuha natin, which is also the same as with the right cosets. Right, let's have another example. This time we have this group, Z sub n na groups. We are all familiar with our Z sub n and we use these examples when we discussed or defined groups. So mga sikat ito na klase ng groups. Of course, our binary operation here again is addition modulo 6. So ang laman ng Z6 again, this is the set. Ano yung set natin dito? It's the set containing 0, 1, 2 hanggang 5. So there are 6 elements because the order is 6. So we are actually partitioning the set of integers depending on the remainder when the integer is divided by 6. So either the remainder is 0, 1, 2, 3, 4, or 5. Now that is the group that is given to us. Now we have a subgroup. It's the set containing 0, 3. Of course, it's already given no na subgroup yan. So you could check in another a time or another paper that this is a subgroup. Indeed, a subgroup of, although we can check naman a subset is a subgroup if that subset is in itself a group under the same binary operation. So dapat closed yan. 0 plus 3 is 3. 0 plus 3 divided by 3, the remainder is still 3. Yes. So, using this subgroup, we're going to create now the left cosets first and the right cosets. Well, of course, we know from our past lectures that Z sub n is also an abelian group. Tama ba? Kaya, well, alam natin right away that the right cosets will be the same as the left cosets. So, parang kukunin lang natin ang left cosets. Anyway, this is an abelian group. The right cosets will just be the same as the left cosets. Now, how do we start? We use the definition na binigay sa atin dito. So, A plus modulo 6 yan, natandaan natin, that is modulo 6. So, perhaps, sige, para mas klaro siguro, edit ko lang konti. Yan. So, we get an element of Z, and then multiply it to the subgroup. But again, the binary operation is addition modulo 6. So, ito yung binary operation. Now, what is the result? So, what could be the first value of A? We can start again with 0. We can start with 0. Actually, sa lahat ng cosets, the subgroup itself is a coset of itself. So, ang unang laging cosets dyan ay siya mismo, yung subgroup. So that is, para lang ipakita natin that this is indeed a coset, is to show that the definition is satisfied, na merong value A na kapag kapag pinerform yung binary operation sa subgroup na yon, ay ibibigay niya yung sarili niya mismo. And this is true for addition modulo n, specifically addition modulo 6. So 0 addition modulo the set 0, 3. So meaning 0 plus 0 divided by 6, the remainder is, of course, 0. 0 plus 3, it's 3. Modulo 6 is 3. So parang 0 remainder 3 pa rin siya. So that should be our first left coset of the subgroup H. Let's proceed computing for the other left coset. So this time we're going to let, normally if we select A, yung wala sa unang left coset. So 0, 3, mamili tayo, element of the group Z sub 6, pero wala siya sa subgroup. So perhaps we could start with 1. So the second left coset is 1 modulo 6, no, addition modulo 6 to the set. So 1 plus 0 is 1, 1 plus 3 is 4. Nagkataon lang, no, mukhang usual addition, pero ano pa rin siya, addition modulo 6. And if we let A equal to 2, the third, this is supposed to be third. Ayan, is this set 2, 5. Now, should we stop? Mag-stop ba tayo dito o meron pang ibang cosets ng subgroup 0, 3? What do you think? Should we stop here? So meaning we have 3 left cosets, or there are other left cosets? What do you think?
Stop na po.
Because why should we
Sir,
stop?
kasi kwan po, na-exhaust na yung all the elements are already present.
Elements of,
C sub 6.
okay, yes. So kaya mas maganda din na isulat natin, no, yung elements hindi na lang natin nakikita yung pangalan ng group. Mas magandang nandito. Okay lang kay Z6 kasi konti lang naman. That's 0 until 5. So 0, 1, 2, 3, 4, tsaka 5. Kompleto naman. That means we were able to identify all the left cosets of the subgroup 0, 3. Itself, the set 1, 4, and the set 2, 5. Again, because Z sub 6 is abelian, addition modulo n is commutative. Kapag pinag-add natin ang dalawang numbers, kahit pagpalitin natin yung order ng pag-add natin, if we divide it by n, the remainder of course would also be the same. So that's the reason why it's an abelian group. So that the right cosets would still be the left cosets. Now, this is a very interesting part of the lesson. And actually, it's part of the topics kung sino yung may-ari ng factor groups, normal subgroups, ganon. This is related. So you will actually be explaining this in more detail when you get to present your topics. Now, andun pa rin tayo sa example number 2. So we partitioned Z sub 6 into cosets using the subgroup 03. Nakakuha tayo ng tatlo. Hayaan na natin yan. Parang we can just use either the left coset or the right coset kasi parehas lang naman sila. So let's just stick with our left cosets so that the figure that we see here, nilagyan lang natin ng shade, light, medium, at saka dark. Yung pagkapangalan niya. So yung part ng body ng Cayley table natin na 03 ang laman, light ang kanyang color. So if you notice 03, 03, 03, 03, 03, 03, lahat yan ay light colors. For the second coset, 1 and 4. So in our Cayley table, na-disarrange lang siya, no? 0, 3, 1, 4, 2, 5 yan. Okay lang yan. So lahat ng 1, 4 ay medium ang pagka-shade. So lahat ng 1, 4. Yan. So I hope you can follow this figure. And then of course, the last coset, the third coset, left coset, 2, 5. So lahat ng mga numbers 2, 5, 2, 5, regardless of the order, basta 2, 5 siya, ay dark. So this table here are summarized here. So light, medium, dark, medium, dark, light, medium. So parang in abstract algebra, sabi natin, it's a study of structures. So, pinalitan natin ang 03 ng isang element na LT. Yung 1,4, pinalitan natin ng medium and dark. Ngayon, if we're going to change this table again to numbers para hindi letters. So, yung LT, palitan natin ng 0. Palitan natin ng 0. Or, yun ba yung ginawa ko? Hindi. Mali yung ginawa ko. Dapat 0, 1, 2. 0, 1. So, this is 0, 1. And these are 2's. Ito. So, I hope na nakuha ninyo, you were able to follow through. Lahat ng LT, palitan ng 0, ng medium, palitan ng 1, and DK, dark, palitan ng 2. What is this? What is this table? Ano to? That is exactly the same as Z sub 3. So, this is a group, right? Whose elements are 0, 1, 2. Kasi modulo 3, the remainders, the possible remainders would be 0, 1, at saka 2. So, how did we form this one? It's formed by using the cosets. So, in this particular example, nung niregroup natin siya using the cosets, nakabuo tayo ng panibagong group. We are not saying that this resulting group is a subgroup of Z6. We are not saying that. We are just saying that using the cosets that we just identified, computed, we were able to construct a different group, but not necessarily a subgroup of Z sub 6. This is Z sub 3. This is exactly Z sub 3. For example, 2 plus 2 is 4 divided by 3. The remainder is 1. Yan. So, saktong-sakto lahat ito sa table na yan. Now, what is our conclusion for this one? Now, I'm not going to write it as a theorem because, again, I'm saying it already. Kung kanino man yung topic na ito sa presentations ninyo, ito yung tinatawag natin na coset group. Because this is a group constructed or comprised of the cosets of a particular subgroup of a given group. But yes, we will see in the coming topics that for a partition of an abelian group, because Z6 is an abelian group, pinartition natin siya into cosets of a subgroup. Reordering the group table according to the elements in the coset always gives rise to such a coset group. And this is really a powerful statement. Kasi kung abelian ng isang group, pwede pa lang natin siyang i-reduce into a different group, especially for groups. Ito kasi okay lang kasi medyo konti. But what if there are instances that your group has a lot of elements, not only 6 elements? And if it's abelian, then marami tayong pwedeng gawin dyan. We can identify the cosets. The cosets will form a entirely different group. Right. That's our second example of cosets. Now, let's provide another one. Example number 3. Now, the group that is given here is the symmetric group S3. So, we recall again what we mean by S sub n. The elements here are permutations of a given set. Since S sub 3 yan, we know that there are 3 elements. So, yung elements natin is like 1, 2, 3. Tapos, dun sa second row ay rearrangement of 1, 2, 3. We know that from our previous lecture. So, that's our given group. And then, the subgroup under consideration here na gagamitin natin to identify its left cosets would be the subgroup generated by mu sub 1. Nilagay ko na dito yung table, the Cayley table for S sub 3 so that it would be easier for us to to multiply later on. Just excuse me for a minute. Balik lang ako after 1 minute. Sorry. Our group here is the symmetric group S3 and we are given here a subgroup set containing the identity element rho sub O and mu sub 1. Rho sub O is the identity element. The other elements here are rho sub 1, rho sub 2. As we presented before, rotations ito ng D sub 3 na nataong parehas na parehas sa S sub 3. Mu sub 1, mu sub 2, mu sub 3 are reflections. Okay. So how do we start? We use again the definition na A times H. Our H here is this subgroup. Now, first is we always start with the identity element. Kagaya ng ginawa natin with the 2 previous examples. Bakit 0? Kasi yun yung nataon identity element ng mga groups na binigay. This time, it's rho sub O. So the first coset is rho sub O H. Again, the binary operation here, since we are talking about S sub 3, is permutation. It's permutation multiplication. So, ang rho sub O, i-multiply natin isa-isa sa laman ng subgroup na binigay. So that means rho sub O times rho sub O, yung pangalawang element, rho sub O times mu sub 1. So the resulting set there is the first left coset. Now, we can use the table to multiply. Or, alam natin yung ibig sabihin ng identity, no? In a permutation, as a permutation, written as a permutation, pwede na namang isulat natin yung identity times identity. Pero we know for sure that identity times the identity mismo ay identity din lang yung sagot. Siguro ito yung gusto nating i-verify, the identity times the mu sub 1. Pero again, identity multiplied. The definition of an identity, when you multiply it to other elements, the result should be that other element. So that it should be mu sub 1. That is the first left coset. Now we choose another A. So of course, ang piliin natin yung wala dyan. Or perhaps we start with P sub 1. So the second left coset would be P sub or rho sub 1 multiplied to all the elements of the given subgroup. So P1 rho 1 times the identity element and rho 1 times mu sub 1. This is a multiplication to the identity element, kaya alam natin na rho sub 1 din. But rho 1 times mu 1, gamitin natin yung table. Or pwedeng isulat natin yung permutation tapos permutation multiplication kagaya ng ginagawa natin previously. Pero meron na tayong table para mas madali tayo makakuha ng sagot. What is rho 1 times mu 1? So, rho 1 times mu 1 will give us this one, mu sub 3. Kaya mu sub 3 yung sagot dyan. Na-exhaust ba natin yung S sub 3? Remember, the elements of S sub 3, symmetric group S3 are rho 1, rho 2, rho 3, mu 1, mu 2, mu 3. 6 in all. Wala pa. 4 pa lang ito. 1, 2, 3, 4. So we need perhaps another one to complete the 6 elements. So we let A equal to rho sub 2. Kasi wala pang rho sub 2 dyan. Kulang pa dyan. So, rho sub 2 multiply to the elements of the given subgroup. Ganun din. So, rho sub 2 yung unang sagot dito kasi identity element. Multiply to the identity element. Now, rho sub 2 times mu sub 1 based from our table, we have rho sub 2 mu 1. The result is mu sub 2. So, were we able to exhaust all the elements of the group S3? Yes. So, obviously, we have 3. Again, 3. Nagkakataon lang, no? Hindi lahat ay 3. Ang cosets. Pwedeng isa, dalawa, or more than. Depende. So, these 3 are the left cosets. Now, obviously, this is not abelian, no? This is a finite set, kaya kitang-kita na hindi siya abelian. Hindi naman symmetric. In a table, or given a table, we know that it is non-abelian if yung nasa upper right triangle ay not symmetric to the lower left triangle. Bakit? Kitang-kita naman, no? Rho sub 1 dito, rho sub 2 dyan. So, hindi agad symmetric. That's enough to say that this is a non-abelian group. So, we cannot say that these are the right cosets also. Kahit dapat iba yan. Hindi natin pwedeng i-assume na sila din. Kaya, kailangan natin i-compute. We do the same. So, the order is important when the group is non-abelian. So, HA. Mauuna yung set, binary operation A. Again, let's start with A equal to the identity element. So, if you notice, baliktad, no? Well, identity times identity yan, hindi yan obvious dyan. Pero yung identity times mu sub 1, naging mu sub 1 times identity. And of course, the result is still mu sub 1. So, nataon lang na parehas yung first right at saka left cosets natin. But if we proceed computing for the second right coset, na yan. Typographical na yan. Right ang kinocompute natin dito, sorry. Yeah, the second right coset is H, the subgroup times row sub 1. So row sub 1, ito, yun na, nag-iba na. Mu sub 1 times row sub 1 is mu sub 2. Ayan. Walang set na, if you compare it to our left coset, walang ganyan sa left coset natin. It's an entirely different set. And lastly, we let A equal to rho sub 2. The third right coset is ito, using the same principle. Rho sub 2, mu sub 3. Again, walang ganyan sa left cosets natin. So, the right cosets are indeed different from our left cosets as presented in this slide. Now, do the left cosets provide a coset group na kagaya ng second example natin kanina? So, to show, let us, because it's finite naman, ang ating group, pwede nating gawan ng table. So, this is the table for, the Cayley table for S sub 3. Na disarrange lang siya, depende sa cosets. So, we are using muna the left cosets. Yan. So, ang elements, row sub O, the identity, and mu sub 1, lahat sila ay light. Yan. Row sub O, mu sub 1, light lahat sila. Yan. Kaya light, lahat yan. Row sub 1, mu sub 3 is medium, and row sub 2, mu sub 2 is dark. Now, do you think this gives us a group? What do you think?
Sir, parang hindi.
Why is that?
Sir, parang based from previous example,
Mm-hmm. Based from previous example, ano yun?
tao po.
Sorry, hindi ko yata narinig na wala.
Ah,
Kindly
Sir,
repeat.
ay
Yes.
sorry, sir. Medyo mahina po kasi yung net. Ay, sir, parang hindi din siya magbibigay kasi the structure itself, sir, is um not abelian or hindi siya yung parang
Mm-hmm.
sir, per square, parang
Yeah.
ganun.
Yes.
Hindi siya yung perfect
Perfect na.
triangle po.
Mm-hmm. Actually, yun yung rason. But if we base it sa table mismo, mapapansin natin, no, na yung product ng, kunyari, ito, yung product ng light at saka dark, so light yung dalawang yan kasi sila yung first coset natin. And this is our third coset. Yung kanilang product, ano? So if I'm going to change this one as LT, if this is DK, ano yung result? Ito. Ano yung result?
Sir, combination. Walang, hindi siya MD.
Oh, tama. Tama naman. And if that happens, then undefined, tama? Hindi natin alam kung pinagsama ang light at saka dark. Dark ba ang sagot or medium yung sagot? So it's confusing. Kung gagamitin natin yung ano yun, definition ng function, hindi siya function. Remember that a binary operation must be a function. So, we were not able to generate a coset group. The cosets does not form a group, and that's the reason. Well, of course, we know kasi that this is non-abelian. But based only from the table that we are seeing here, well, hindi naman nga talaga. Actually, there are other instances. Halimbawa, yung dark, the third coset times the third coset gives us different answers. May medium at saka may light. Ganun din sa third coset times the second coset, ito yung sagot niya ay halo-halo din. So, hindi kasi kagaya kanina na very definite yung sagot. Kaya nakapagbigay siya ng group, nakabuo siya ng group. In this case, in this example, no, it doesn't form a coset group. So remember, a coset group is a different type of group created by or formed by the cosets of a particular subgroup of a group. Ayan, medyo intertwined na yung mga objects natin. I hope you can follow. Kapag sinabing cosets, cosets ng anong subgroup muna. Anong subgroup yung ginamit para mabuo yung mga left cosets or right cosets? And then, ano ba ang group na kino-consider na kung saan nakuha yung subgroup na ginamit mo in identifying the left or right cosets? Okay. So now, we proceed to a very powerful theorem. This is called the Theorem of Lagrange. Very powerful kasi it, of course, ang application niya, it shortens our computations, no? And this theorem is also the basis of a lot of theorems that we will encounter later on. So what is the Theorem of Lagrange? It's about the orders of subgroups and the group from which it is a subgroup. So H is the subgroup of the group G. So what about the orders na sinasabi ni Lagrange? The theorem of Lagrange. Yung order, remember order is pertaining to the number of elements of the set. Yung order ng subgroup natin, if it's a subgroup, then it should divide the order of the group. Anong ibig sabihin ng divide? It divides. Dapat divisible yung order ng G, divisible by the order of H. Moreover, the number of distinct left or right cosets of H in G is that quotient. So the order of G divided by H, the order of H. Kung ano yung number na makuha, so that is an integer, that should be an integer. Yung number na makukuha natin dyan, yun yung number of elements ng mga cosets, left or right. Now, before, I think I prepared here a proof ng theorem na ito. Before we proceed to that, let's provide muna some examples. Gamitin natin yung mga examples na binigay natin in the previous slides. So, halimbawa, ang cosets ng subgroup na 0, 3, and Z sub 6, tatlo ang nakuha natin. Remember that the order of Z sub 6 is 6 and the order of the subgroup 0, 3 is 2. So, the quotient is 6 over 2, which is 3. And we have 3 number of cosets. So the number of distinct, ito yung pinapakita natin dito. Ilan ba ang left or right cosets? That is the order of the group divided by the order of the subgroup used to generate the cosets 3. So the 3 here represents the 3 cosets, left cosets. And of course, the first statement na about the divisibility. So, kitang-kita naman natin na na-divide nga yung order ng subgroup, na-divide nga yung order ng group. Kasi nga, integer yung sagot. So, 6 is divisible by 2, obviously. Also, with our left and right cosets, sa third example natin kanina, the same can be observed. So, 6 din ang laman ng S3 natin. 3 factorial is 6. And the order of the subgroup is 2. So 6 is divisible by 2. And that answer 3 is the number of the left or right cosets generated. There are 3 left cosets and there are 3 right cosets. Okay. However, I have a warning here. I had to include it here kasi a lot of students misinterpret this one. So yung theorem, yung sinasabi niya, if H is a subgroup of a finite group, finite pa siya ha, it's limited only to finite groups. Kapag given kapag given na H is a subgroup of G, then the order of H divides the order of G. Pero, magbibigay tayo ng example. Ito, no? Let G be a group of order 323. So, ang dami niyang elements. So, 323, by the way, is the product of the two prime numbers 19 and 17. It follows that the divisor of 323 are 1, 17, 19, and 323. Now, true or false? True or false? Merong subgroup ang group G na ang order niya ay 17. Is that true or false? There exists a subgroup H of this group na naglalaman ng 323. Merong subgroup na ang kaniyang order ay 17. Meaning, a subgroup that has 17 elements. Is that true or false? Anyone? A true or false lang tayo. Tignan natin.
Sir, false po ba?
Yes. Why is that?
Kasi like, ay, sige po.
Sige lang. Please explain.
Sir, pag naalala ko po kasi usually or based on observation, usually yung mga elements, buti sana kung may 17 elements din. Parang ganun po ba?
Based from the theorem tayo. Bakit false 'yun? Hindi ba siya kasama sa theorem? Is that not the theorem what's talking about? Is that not the point na nandito sa theorem? And actually, you're correct of saying it's false. But why is that? Ang statement ko kanina, there is a subgroup whose order is 17 because 17 divides 323. So, actually, it does not satisfy this theorem because it says here that only if a given subset is a subgroup of G, then it's possible that the order is either, actually, ang 1 at saka 323 na yan, those are the orders of the trivial subgroup in the group itself because the group is a subgroup of itself. But sa 17 and 19, are we to expect that this group having 323, meron at merong subgroup na ang kaniyang order ay 17 or 19? The answer is false. Kasi ang sinasabi ng theorem, kung lang ang isang subset ay binigay na subgroup or napatunayan natin na subgroup, doon natin i-assume na either 17 or 19 yung kaniyang order. Pero hindi ibig sabihin na because a number divides the order of the group, meron at merong subgroup. Meron at merong subgroup na ang kanyang order ay 17 o 19. Were you able to understand what I mean? Yung difference? Anyone? Nakuha ba yun? Naintindihan ba yun?
Sir, medyo.
So, ito. If A is a subgroup of G, true or false pa rin tayo. A is a subgroup of G. A proper subgroup, to be specific, of G. Then the order may be 17 or 19. Is that true or false? True or false tayo?
False, sir.
False kaya? Kasi A is a subgroup of G. Itong G na ito. So it's given that it is a subgroup. Then,
Sir, true.
yes,
Kasi,
it
kasi
must be,
na-indicate na subgroup, sir.
yes,
So, sir, dapat na-indicate doon na, ay sorry, sir. Na-indicate siya na subgroup siya para
para
magamit yung
yung
theorem, sir.
theorem. Yes.
Okay.
Okay. Kasi, di ba ang sabi natin kanina, kung walang binigay na subgroup, tapos nag-assume tayo na merong subgroup na ang kanyang order ay 1719, that might not be true. That could be true, that might not be true. Hindi siya definite. Pero kung binigay na siya na subgroup of a particular group, then we can say that whatever happens, whatever the order, that order should divide 323. Ito, possible subgroup order ay 117, 19, 323. Anong ibig sabihin din nun? Maaaring itong group ay wala siyang subgroup na 17 or 19. Pero kung may binigay na subgroup, one of the possible order is 17 or 19, provided that that is a proper subgroup. Yung 1 and 20, 323, they are actually the order of the itself, the group, and the trivial subgroup. Yung identity element natin, of course. Ito yung ini-explain niya, yung nandito sa baba. Ano yung we prove this in example 4?
Sir, pwedeng isang example pa po dun sa Lagrange?
What do you mean language?
Dun sa yan, sir, sa Theorem of Lagrange,
Lagrange.
Lagrange, sorry, sir. Isang example pa po.
Sige. Let's have do you have your notes with our previous lectures? Yung Z18 or Z12, Z sub 12. Sige, saglit. Mag-open tayo. There. Can you see this presentation? These are our previous lessons. So ito yung group natin. U of 15, our binary operation is multiplication modulo 15. And these are the subgroups. So given na subgroups ang mga yan, no? Nakikita na natin na subgroups ang mga yan. Now, we are going to satisfy the theorem of Lagrange. That is, the order of any subgroup, it should divide the order of the group. So, the order of the group is 1, 2, 3, 4 hanggang 14. That gives us 1, 2, 3, 4, 5, 6, 7, 8. 8. 8 yung order ng ating group dito. Well, of course, ang order ng first group natin ay 1. So, 1 divides 8, obviously. 8 divided by 1 is 8, an integer. Ang order dito ay 4. So, 4 divides 8. 4 divides 8. 2, ang order dito ay 2. 2 divides 8. 4 divides 8. Actually, kapag titignan natin lahat ng subgroup dito, ang kanyang order ay 1, 2, 4. Walang subgroup of order 8. Tama ba? Tama ba? So, iyon yung sinasabi ni Lagrange. Although, how many possible numbers are there that can divide 8? Ilan ba yung integers na kayang mag-divide ng 8 na siyang order ng group? 1, ano pa? 2, ano pa? 3,
4, sir.
4, sorry. Ano pa? May isa pa.
8.
8. Yan, tama. Meron ba tayong nakitang subgroup na 8 ang kanyang order?
Wala, sir.
Yun yung sinasabi ni Lagrange. Hindi porket a number divides the order of a group, meron na agad-agad na subgroup na ang order niya ay 8. Kaya lang, kung yung binigay sa atin na set ay subgroup, for sure, ang kaniyang order will divide 8. Do you get the comparison now?
Opo, sir.
Alright. Let's go back to our slide. Okay, sinipag ako eh. This is the proof of the theorem of Lagrange. Before we are able to show the proof, we need another theorem actually. So, yun yung ipapakita natin muna. Every coset, left or right, of a subgroup H of a group G has the same number of elements as H. Although, as an observation, yun yung nangyari kanina. Kung yung subgroup na binigay ay dalawa yung elements, syempre, ganun din yung elements ng mga cosets na mabubuo, right or left. Bakit? Kasi ang gagawin lang naman natin sa pagbuo ng cosets ay mag-multiply ng A doon sa lahat ng elements ng H na ito. So kung dalawa lang yung elements niyan, dalawang beses ka mag-multiply ng A. Or kung 5 ang elements ng H, 5 beses ka mag-multiply ng A. Depende na kung ano yung binary operation na involved. But the proof is, we show that there is a 1-to-1. So, pag the same number yung pinag-uusapan, normally yung proof ay to show that it is a bijection. There is a function that is a bijection. When we say a bijection, it has to be both 1-to-1 and onto. So, yung mapping natin dyan ay ito. We're going to define a mapping from the subgroup H. Of course, we are pertaining to the set mismo dito, mapping to the coset. Coset ito, the left coset to be specific, G of H. So, when do we say that there is a 1-to-1 correspondence? If phi of H, there are two elements. Saan nga ulit tayo? Yeah. It is 1-to-1 because lahat ng elements ng G of H naman, of course, ay meron siyang pre-image in H. And it is onto kasi by definition, yung range natin mismo ay itong set na ito, GH. But this is our proof. To show that it is 1-to-1, we're going to take two elements, H1 and H2 of this set, yung sa ating codomain, galing yan sa codomain, H1 at saka H2. And, hindi. It's galing from our domain. And if we apply the function, so phi of H1, phi of H2, this implies that GH1 and GH2 are the same. And how is that? Because of the cancellation law for groups. Present din natin ito in the previous lessons na cancellation law is applicable provided that it is a group. We are working with a group. So cancellation is like, diba? Kinancel natin yung parehas na element kasi they are of the same direction. So we have H1 is equal to H2. Now, this is the theorem of Lagrange na gusto nating bigyan ng proof. In symbol, ang theorem of Lagrange ay if H is a subgroup of G, that is a symbol for the subgroup, di natin siya babasahing less than or equal to, then the order of H divides the order of G. Yun lang naman yung ipapakita natin. And how do we start? Of course, we're going to make use of the first statement na pre-move natin. So let N be the order of G and H, ang kanyang order ay M. Now, every coset of H has also M elements, as this statement is saying. And we let R be the number of cells in the partition of G. Because cosets is, again, a partitioning, tama? So, ang R, that is like referring to the number of cosets na meron. Cosets of the subgroup H. That is a partitioning of G. So, then, N is equal to Rm. So, M is indeed a divisor of N. Now, we're going to discuss it again in layman's term or in a simpler term with an illustration. Ano ba yung sinasabi nito? We start with the group, and that group is represented by a rectangle, the big yellow box here, box na lang. It's finite, kaya pwede natin gawin ito. The group that we are talking about for the theorem of Lagrange is a finite one. So, G is this group. So, syempre may mga laman yan. And, i-partition natin siya. Kaya naging ganyan. Partitions ang mga yan. Bawat partition, meaning bawat red box, ay merong M elements. Ang M, hindi yan yung element. It's referring to the order. Kung ilang elements ang nandyan sa bawat box. Yun ang nakikita natin na M. So, ilan ang elements lahat-lahat ng big yellow box? That is precisely kung ilang yung red box times the number of elements in each box. That would give us the elements of the given group. That's why we have N is equal to Rm here. Kasi ang N, which is again the order of G, is just the product of the number of red box dito and the number of elements in each box. Ano naman na yon? Parang intuitive naman natin yun na maiintindihan. Siyempre. So, yan. That's actually the proof. M is indeed a divisor of N. Because, i-divide natin ng ano, kapag i-divide natin ito, yung equation na ito ng M, ang sagot ay R. At ang R ay integer because it's referring to the number of box. Hindi naman pwedeng 1.5 box. Tama? That's always an integer kasi cosets yan. Number of cosets. Hindi naman pwedeng hatiin yung set, no? Half na coset, walang ganon. So it's always an integer. So that's why hindi siya explicitly na minention dito, but this means that N is indeed, or M is indeed divisible or divides N because when we divide it by this equation by M, ang result ay R. So N over M is equal to R. And R is representing the number of box, paulit-ulit, and R is an integer. Should be an integer. Now, we have corollaries from the theorem of Lagrange. Mga count theorems ang mga ito. It says here that every group of prime order is cyclic. Now, tandaan natin yan. This will help us in problems. For example, is the group cyclic? What if it so happened that the order of that group is prime? The answer is, agad-agad using this corollary, yes. So, for example, is the group Z sub 19 cyclic? That's the question. Is a group Z sub 19 cyclic? Yes or no?
Yes, sir.
Yes, because
Z sub 19, sir, is a prime order.
is of prime. Yes. Tama. Kanina, yung example natin kanina no na U sub 15. Yung U sub 15. Ilan yung elements na ulit kanina?
8, sir.
8. Cyclic ba siya?
No, sir.
Kaya, it matches, tama ba? Na walang subgroup na naka-generate, wala siyang generator. Kasi, ang definition naman ng cyclic group ay, it's a group generated by an element of itself. An element from the group. At nakita natin kay U sub 15, not sub 15, U of 15, na lahat ng kanyang subgroups ay proper subgroup. Wala siyang generator. Kaya yung group na yon ay hindi. Because it's not prime. O hindi siya cyclic. Pero kung prime yan, it's cyclic. Although hindi pala natin sinasabi na kapag hindi prime ay hindi na siya cyclic. No. That is a false statement if our basis is only this corollary. Kapag prime siya, ang order ng isang group, that's automatic to be cyclic. Pero kung hindi, hindi naman niya sinasabi na kung hindi siya prime ay hindi siya cyclic. So we cannot assume that one. That's specific only for the example U of 15 kanina. Another theorem, the order of an element of a finite group divides the order of the group. Actually, that's the same, no? Of the theorem of Lagrange. Pero we are referring to the order of element pala dito of a finite group. Remember that the order of an element is not the same as the order of the group or even the subgroup. The theorem of Lagrange is saying that the order of a subgroup divides the order of a group. In this theorem, it's saying that the order of an element, yung element mismo of a finite group divides the order of the group. Ano na yung order ng element? Yun yung nakapower. Halimbawa, A is an element of the group. If A sub n, A raised to n gives us the identity element, whatever that group may be is, then n is the order of that particular element. Yung halimbawa natin before, nagbigay tayo ng meaning ng order of element kasi previously. So halimbawa sa Z sub 6, tapos ano yung order ng 2? Anong ibig sabihin nun? Ano yung exponent dapat ng 2 para bumalik siya sa identity element? Ano yung identity element? 0. So parang 2 plus 2 plus 2 hanggang saan para bumalik ka sa identity element? And that is 2 plus 2 plus 2. So 2 raised to 3, no? Will give us a remainder of 0, which is the identity element. So ang kanyang order in Z6, order of 2 in Z6 sub 6 is 3. And 3, yung 3 na yon na order ng element, ang sinasabi niya dito, it divides the order of the group, which is 6, which is true naman in that particular example. Another definition for what we mean index. And the notation there is, isulat natin yung G, tapos colon, and then the subgroup H, and then parenthesis. This is just a number. This means the index of H in G. Let H be a subgroup of G, group G. The number of left cosets, so ang ibig sabihin ng index ay kung ilan ang left cosets ng subgroup H in G. Bilangin natin. So kanina, dahil 3 ang number ng left cosets of this set, of this subgroup, then the index, di ba? So, paano yung pagkasulat natin? The group, the given group, colon, and then the subgroup. Well, the subgroup is a set. Pwede na naman nating pangalan ng let H equal to this set para H yung isulat natin dyan. Or, we can write it directly like this. The index is 3. Similarly, nataon lang na 3 din yung kanyang index kasi there are 3 subgroups. 3 cosets. So, there are 3 cosets of the subgroup H and Z sub 6. Yun yung ibig sabihin ng index. And we have here another theorem. It's saying that suppose H and K are subgroups of the group G such that, ito na naman tayo, hindi ito less than or equal to we are talking about groups and subgroups. These are notations of subgroups. So anong ibig sabihin nito? H is a subgroup of G and K is a subgroup of H. And suppose that the index HK and the index GH are both finite, then the index GK is also finite. And precisely how do we compute the index of this, of K in G? It's simply the product of the two. So, tignan natin yung yung premise. Meron tayong group, meron siyang subgroup H. Because subgroup is a group na taon na meron siyang subgroup ulit. Parang subgroup of a subgroup. Meron siyang subgroup na K. So K is a subgroup of H and H is a subgroup of G. Kung binigay sa atin ang index ng H in G, meaning how many left cosets are there, left cosets of H in G. This is that quantity. And also, how many left cosets of K are there in H? How many left cosets of K in H? The product of these two numbers, if we multiply it, that will give us the index of K. Parang parang composition. K, the index of K, the number of left cosets, yun yung ibig sabihin ng index of K in G is given by the product. Alright. And then, ito yung last part of our lecture today, normal subgroups. But, actually, I only considered the first few parts, because this is, again, a topic that is supposed to be discussed together with the topics na binigay ko sa inyo. Factor groups and all. Kasi related sila. But anyway, still related din kasi siya sa cosets. So, I will initially discuss it and then ituloy nyo na lang kung ano man yung hindi covered in this slide. Normal subgroups. Normal subgroups. Definition: you are given a subgroup H of a group G, and that subgroup H is called normal if its left and right cosets coincide. That is, GH is equal to HG for all G element of the group G. Now, magbigay tayo ng halimbawa. Of course, the first example here are our abelian groups. If we know that the group is abelian, the cosets, the subgroup that yields cosets is called a normal subgroup. So yung normal subgroup, it is referring to the subgroup na ginamit sa pagbuo ng coset. Kung yung subgroup na yun na ginamit, parehas yung ma-generate niya left and right, then it's called a normal subgroup. Because not all subgroups, di ba, ay nagbibigay ng parehas na cosets, na left and right cosets. Nagpakita tayo ng halimbawa kanina, that's for the case of a non-abelian group. Yung yung permutation, yung S sub 3, nakita natin na yung elements generated by rho sub O and mu sub 1 yata yun yung subgroup na ginamit. Iba yung nakuha natin na left cosets at saka right cosets. The subgroup na set containing rho sub O and mu sub 1, that is not considered a normal subgroup. Because, well, it does not satisfy the definition. For abelian groups, we are actually generalizing it already here, that if it's abelian, the subgroup is normal. Kasi parehas yung ibibigay niya na right at saka left coset. By the way, for cases na for normal subgroups, actually general na yung pagtawag natin, hindi na natin siya tinatawag na left and right cosets. Kasi alam natin in our mind na because it's abelian, because it's a normal subgroup, it gives the same right and left cosets. Kaya coset na lang. Pero kung iba, kung alam natin na iba yung right at left cosets, then we have to be specific. We say it's the left cosets or the right cosets. What are other kinds of or examples of a normal subgroup? Or kailan nagkakaroon ng subgroup? We have our alternating group. Again, ang alternating group galing yan sa Sn, S sub n. We just collected only the even permutations. Even permutations are those permutations that can be expressed as even number of transpositions. If you can express it as a transposition and there are even number of transpositions, then it's an even permutation. So kapag kinolect natin lahat ng even permutation na yon in S sub n, we call it A sub n, that group is a normal subgroup of Sn. So yung mismong An is a normal subgroup. We can use this one to create cosets na parehas ang left and right. Another example, when can we have a normal subgroup? The subgroup of D sub n, dihedral groups, if we are going to consider only the subgroup consisting of the rotations. Remember, in dihedral groups, dalawa ang pag-create ng elements. Either you rotate it or you take the reflections. Ngayon, tanggalin natin lahat ng mga reflections. Maiiwan lang yung mga rotations. Yung subset na yon is a subgroup. And more specifically, it is again a normal subgroup. Yun yung sinasabi niya dito. Okay. There's another way of understanding this, no? So remember that the subgroup here is used to create cosets. So yung subgroup na yon ginamit natin to form the cosets. Sabi natin left cosets. If those left cosets form a group, meaning there is a coset group, that's also the time we say that the subgroup is normal. Yeah, so that is like an idea derived from this definition. I am very sure that you will be repeating that in your own presentation because it's included there. Yes. So that is actually the end of my presentation today. Any question? May tanong ba tayo?
All good, sir. Sir, pero clue kung sino
Ano naman,
magdi-discuss.
sir?
Yes, ano yan?
Clue, sir, kung sino mag-discuss ng mga need.